Hi, everybody. Welcome to episode 5 of Robo Weekly. Episode 5. I can't believe we made it. Dan Saw, my co-host. How are you today?
I'm fine.
5. For me, 5 is pay the line, pay the field. 5 for those who play craps. Always take maximum odds on 5. What does 5 mean to you?
Well, I've often wondered why we have 5 fingers on each hand. And doing the robotics research that we've been doing, there's everything from grippers to, full human type hands. I haven't seen anyone do 6 or 7 or 8 fingers. That would be interesting.
We see a lot of 2s and 3s, a lot of 2s and 3s pincers.
True.
I guess 5 is.
And going back, many years, people learn to use prosthetics when they lose a limb, and they can do some pretty impressive things, even with just sort of like a pincer sort of arrangement. But I
like
do
a pirate.
Yeah, like a what?
A pirate.
Oh, a pirate. Well, they got a hook, right?
They have a hook. That's right.
I think an important question is, what tasks require more complicated manipulators than a gripper? We've seen some pretty impressive videos of like Physical Intelligence and other companies using open VLA models, which we're going to talk about today, I think. They do it with basically 2-fingered hands, folding clothes and picking things up and putting them in the dish rack and stuff like that. So
yeah, and I've seen suction as well quite often,
right?
Which
for pick and place,
which certainly has a place. Before we start talking about today's Robo news, which is, of course, is why we're here, I'd just like to encourage people. I know we've had a lot of views last week, which was great. Not a lot of comments. I want to remind people that we were going to show our robot in our lab this week. It's not happening. We're not quite ready to show it. We will do next week. We are giving away 2 robots, one to a subscriber and one to a comment of best use case. So please comment. We promise to comment back.
Let me just say this is a safe space. We're not going to jump all over you if you ask a newbie question.
That's
and
right.
If somebody does, I'll slap them down.
Okay, let's start moving forward with today's Robo news. Joe, if you could bring up slide number 1, please. This is one of the few really success cases. It's funny, since CES, where we saw a lot of home robots, we've now sort of settled back into robots that actually work. This is the famous Moxy. It delivers chemotherapy drugs and other drugs around hospitals. It's in the news this week because it's done its millionth delivery. It really is a success story. It's just basically a moving basket. You can see it pushing the button on an elevator, but a success it is. Dan.
Yeah. Well, it often makes a lot of sense to go for a vertical market with a new technology, because you can limit the sort of capability that you need to precisely do the task that's at hand. A similar example is how the Digit robot from Agility, which is focusing very, very strongly on warehouse, movement and warehousing and stuff like that. So yeah, kudos to them. The other thing about a vertical market is you can price it much differently than a consumer product. So we're shooting for the brass ring with the idea of being in the home. I think what we may talk about today is what the timeline for that is going to be. But it certainly makes sense for some companies to go and find a niche market like this and just really attack it with a targeted solution.
Certainly, what we can say is that if you've got 50,000 to throw at it, you can get it to work.
Yeah.
And again, what we're going to talk about is the challenges of trying to do that at less than at a number that makes sense to most people in the home,
right?
Which is not 50,000. Okay, let's move to our second slide. By the way, Moxy some diligence, just to let everyone know. This is just in the news today. Aptronic, which has this robot here called Apollo. You can see it has a Mercedes insignia on it. It's in a factory. So Aptronic has just raised Series B, 350 million from a number of investors, including Google, who are not the lead, but are a significant continuing investor. This is an expensive industrial robot, but it is a humanoid. It's talking about hands. It does appear to have 5 4 fingers and an opposable thumb. It's expensive. It's called Apollo. They've raised a ton of money to do more of this. This is obviously not going to be in the home, but this is what stuff's going to look like. Do you like it?
Well, it looks a bit like a prototype, right? There's a lot of wires hanging out, but yeah, I mean, I'm not sure why they gave it a face. That gets into the whole uncanny valley, question. If they're going to be like the Moxy and focus on a specific vertical, maybe that'll do well for them. I don't see the bottom half. Is it wheeled or legged?
No, it's on legs, and I believe it is a general purpose robot, not a vertical.
Right.
So I think probably that's why. That was news just because of the raise. So that's where a lot of money's going. Again, that's going to be on the factory floor at that price. But we can see what things might look like. It's always good to see that. We're going to move to something a little more frivolous. I don't know if I want to use the word frivolous, but it's certainly different. This is from Ep5. It's out of a lab. It's made out of hollow tubes. It's a shape-shifting thing. We don't have a video of it. You can imagine that as it tumbles over the ground, its hollow tubes adjust its shape so it can literally go over a mountain. I'm just showing this because it's always good to see what other people are thinking. It's not all about bipeds and things that look like humans. This is an interesting shape that may exist in the home. I mean, why not? This can get up the stairs. It can probably do things. Do you think these kinds of shapes might have a place in the home?
Well, there's a long tradition of like snake robots and what they call soft robots, and there's been a lot of research into that, and this seems to come from that realm. I think they're interesting conversation pieces. I'm not sure what they do practically that's very helpful, but some research is not meant to produce immediate commercial results, but just to get you thinking and explore sort of unexplored spaces of possible solutions.
Okay. Well, I think as we know, although there's some exploration going on, there's a reason why we're making robots to look like humans, because the spaces that we exist in are built for the human form factor. Let's take a look at the fourth one, which is Engine AI. They purport, we're going to see a video here, they are purporting that their robot will do the first backflip. That's just a fun little thing. That one's got no head. We have no price, but it does a backflip. Can't imagine it's cheap, but that
looks like it's a front flip. That's not a backflip.
Oh, well, I think if we keep watching the video, eventually it's going to do a backflip, because that was the news. Here we go. No, I thought that looks like
turn the camera upside down. It'll be a backflip.
All right. Well, anyway, that's
he said front flip.
I'm sorry. It is front flip. Okay, which I guess may be more difficult than backflip. I don't know.
He's got a good walking stride.
Yes, it doesn't look like doesn't look like it's got a diaper fill. Well, it's got those hip actuators that we've actually experimented with.
And I'm sure they worked with motion capture.
Right.
To get that going. That's nice.
Well, talking about motion capture, that's going to lead us into our next segment, I think, which is I'd like to get your opinion on what we can expect in the next 12 months. What I emphasized last time is we're seeing a lot of stuff that we don't believe is real. Yet we're going to see products start coming out. In fact,
some of it's more real than others.
Yeah, and we're going to show our product next week, which we're very excited about. There's only $2,500, which is quite incredible for a full-size robot that's going to be able to eventually do whatever you want. But I do want to temper people's expectations. Transformer technology, which has been focused like a laser beam on media, is now starting to get focused on embodiment. I'd like you to talk about what that means, as opposed to just working on text and images, and how that relates to robots and planning, and what we can expect from robots in the next 6 months and moving forward from that.
Well, these are good questions. So the piece of technology, the tagline that people are using, the jargon is VLA, Vision Language Action models. And there's something called Open VLA, and that actually the people who worked on that are now at Physical Intelligence with lots of capital to work on their ideas. They open sourced something they call Pi Zero. These articles that you sent me from the people at Cobot, they're sort of pushing back on this, the idea that the Transformer is going to just, shoot everything ahead at light speed into a singularity of robot competence. And their pushback is based on the fact that unlike the language and the video and vision and, graphics capabilities that we've seen in LLMs in the last couple of years, robotics suffers from a severe lack of data, because capturing the data is very hard, and there isn't, people don't sit at home and watch 4 hours of motion capture, of robots, pouring tea and stuff. So you don't have the internet, for a GPT, the trillions.
So can robots watch YouTube videos of people doing stuff and sort of dream about it and train
That's a good
themselves?
question. People, I think they call that reflection training or mirror training. And that seems to be what humans and primates do, right? To a large degree, right? They sort of model their behavior after your behavior. That's a little more complicated than you might think. It means projecting your body form into somebody else's, into a machine, and rather projecting your body, your robot body, onto the model of the thing you're actually watching. So that's not trivial. What seems to work better is to have joint angles and 3D information about everything that's going on in the scene. And that requires people with special setups to do teleoperation. So basically, the state of the art right now is to do teleoperation on, thousands and thousands. And they wish they could do millions, but it's hard to get that data. There is some data set that I think is about 2 million robot movements. And that seems to be what a lot of people have started with. And you see some impressive results. Again, these are YouTube videos. It's kind of hard to know how many takes they did and what's staged and what's realistic. You have that experience of the Tesla robot, the Optimus at some Tesla event.
If you don't mind me interrupting, you talk about
Sure.
a dearth of data. And we hear that there's a move towards synthetic data,
Right.
which we hear there's a problem. It tends to get stuck in local max and minima, which is an issue.
Well, I think
it falls in on itself after a while.
Well, if you don't have enough data, yeah, that's what happens.
Right.
You overfit. The problem here is that, but with the training data being synthetic, is this gets back to what we've discussed before about physics engines. There isn't really a physics engine that I'm aware of that can emulate a kitchen with pots and pans and grease on the pans and a cup with liquid in it. The folks at Google just came out with
that's because I think most physics engines were designed
for games,
for gaming.
Right? For games or movies, yeah, exactly. And there are more sophisticated physics simulation approaches that you can take, which I think we're actually very interested in. That simulation sort of being my background in this field. I'm not really a hardware tinkerer. I depend on people like some of our cohorts. But right, so it's just really hard to get synthetic data around this problem. I think they were able to do a lot of synthetic data for vision models because they can have. It's just a different problem. But getting into action models, and I've not seen anybody doing an action model that's based on a physics engine, for instance, on synthetic data. That seems to be an open field.
So let's talk about what customers can expect. We're going to probably start seeing a raft of robots coming out, not only ours, but I'm guessing there's going to be a few other people that are coming out with what we're calling an MVR, minimum viable robot, a robot that can do basic things at a cheap price. I think we might be the first. We don't know. We're going to be out in 2 months. And we'll show it next week. But what can people expect from these types of robots? I mean, what for these MVRs, what are they going to be able to do? I mean, before they're trained, obviously, and they have a model that's sophisticated, that they're only going to be able to do certain things. But is the same hardware going to be able to do more and more as they get more and more training?
Absolutely. But you may also find that you should have done the hardware slightly differently to get a better result. And you're going to iterate on the hardware as well. and how that works with customers and beta and upgrades and stuff. Software upgrade's a lot cheaper than a hardware upgrade, right? So a lot of this data that these VLA models were based on is one arm, like a Franca arm, and they're these industrial robots with very precise, strong arms.
Like the Fanuc.
They're like the Fanuc and the Franca. And aside from the fact that they're very expensive and they're designed for work in the factory and stuff like that, and they're actually not safe to be around because they're too strong. So I don't know how well that translates to like sort of, two arms with, less strength, but more dexterity or more reach, which is kind of the direction that we're going, and maybe some others will go. I think this issue of generating the data is going to be huge. It's going to be the primary blocking. I think that's going to be the cinch point. The hardest part to get through, the weakest link in the chain, if you will.
And in fact, that's one of the things we want to do, and that's why we have this podcast, and that's why we're trying to seed the market with hardware, is that we want to try and get a collaborative, open source.
Right, that's a good. Yeah, thank you for reminding me about that. We talked about that last week, but what we really want to do is get a lot of people, ideally thousands of people, to buy like a cheap but capable robot, and to do work with that robot and create more data that we then put back into I think someone said that I invented the word cloud source. So like cloud source the data necessary to bring us to the next step. But it's going to take a couple of years for sure.
But it's going to be able to do something.
Yeah, it'll probably be able to. I mean, the first robots will be able to pick things up if they can get to the floor, which is an interesting question, and maybe put them away. Maybe do a dish rack. Probably not wash the dishes because you got liquid and you got soap, and that becomes a complicated thing.
To me, the killer app was always to bring me something. Do you think that?
Yeah. I think it should be able to open the fridge, get a beer, take the cap off the beer, and bring it to you. I think that's a worthy goal. That's something that we're looking at trying to do.
Bring me a beer or hold my beer.
Hold my beer.
Okay, well, great. I think that's extremely useful. I think that's a good foundation for further conversations about where the LLM, the transform model, are going to head in the embodying world. I'd like to thank you all for watching. I'd like to encourage you to comment. I promise you will reply. And thank you for watching Robo Weekly.
Oh my.
That was great.